So hey there, how are you doing? This particular video is going to focus on graphing the inverse functions, cosine inverse, sine inverse, and tangent inverse. And it wants me to find the domain and the range of them. Let's talk about graphing the cosine inverse function first. Okay, before I actually graph this, I want to go back and remind us of what the cosine function looks like. Are you with me? So let me sidetrack you a moment. Let me go over here to the cosine function. And the cosine function, we had 0, pi over 2, pi, 3 pi over 2, and then 2 pi, don't we? And if we looked at the cosine of 0, that was 1. And then the cosine at pi over 2, by the way, let me write this down just so you know, you remember what we're graphing. This is 0, cosine of pi is -1, 3 pi over 2 is 0, 2 pi, right? So this would be my cosine function. Agreed? Okay, and it is a function, and it passes the vertical line test. Now, if I look at its domain, the domain technically is -infinity to positive infinity, right? And then the range would be from -1 to +1, right? Okay. But for it to have an inverse, the cosine function has to be a one-to-one function. Are you with me? And one-to-one functions not only pass the vertical line test, but they also have to pass the horizontal line test. Which means, if I pass a horizontal line through any part of this graph, it's going to touch it more than once, which means this is not a one-to-one function. For me to make cosine a one-to-one function, I have got to limit its domain. I can't let the domain be all real numbers from -infinity to +infinity. I can't do that. I have to limit the domain. So what we're going to do, in order for us to have a one-to-one function, for the cosine graph, I am going to limit the domain from 0 to pi over 2. And when I do that, now this is technically a one-to-one function, because not only does it pass the vertical line test, it also passes the horizontal line test. Are you with me? And it's also a side benefit. It also gives me positive y's and negative y's as well. All right, so let's look at the cosine inverse graph. Hopefully this makes sense to you of why we had to limit the domain. And by the way, we're not limiting the range. The range is still going to be from -1 to +1. Are you with me? Okay. So let's go over here to the cosine inverse. Now remember, when you talk about the inverse function, the x's and the y's switch places. So technically these are my x's and these are my y's, aren't they? So now my y's become my x's, which means we go from -1 to +1. Ah, well, doesn't that mean then the domain of this inverse graph, doesn't that mean the domain is going to be from -1 to +1, since the y's switch to become the x's on the inverse? Got it. And my x's become my y's. So my x's are basically going from 0 to pi, excuse me, not pi over 2, pi. I know some of you were saying pi and I just didn't hear you well enough. Sorry about that. Pi. So it's going first and second quadrant. Sorry about that. So now my x's become my y values. So my y values are basically going from 0 to pi. So we have 0, here's pi over 2, and here's pi. Ah, but wait. The x's switch to the y's, which means they become the range. which means the range goes from 0 to pi. That's the nice thing about one-to-one functions. The domain becomes the range, and the range becomes the domain. All right, now let's graph it. This point is 0, 1. Well, that means 1, 0 on the inverse. This point is pi over 2, 0. Well, on the inverse, it would be 0, pi over 2. It switches. This point is pi, negative 1. Well, on the inverse, it's going to be negative 1 and pi. It switches. So we kind of have this graph going on for our cosine inverse function. Does that make sense? Okay. We still have sine inverse and tangent inverse to do. So if you need to kind of review what we did over here before you move on to the next part of the video, which is going to talk about the sine inverse function, then please do so. And in the meantime, I'll be right back. Okay, so we're back to graph the sine inverse function, and we need to find its domain and range as well. So before I graph this, let me go to the sine function itself. So if we remember to graph this sine function, let me get my quadrant markers down, so to speak, my quadrant angles down. Okay, so if we remember, the sine at 0 was 0. And then the sine at pi over 2 was 1. And at pi is 0. And at 3 pi over 2 is negative 1. And at 2 pi is 0. So we kind of got this mountain to the valley graph, right? And if we look at its domain is negative infinity to positive infinity. And its range is negative 1 to positive 1. Good? Okay. But if it's going to have an inverse, not only is it supposed to be a function, but it's supposed to be a one-to-one function. And we have a challenge here, because when I draw the horizontal line, this fails on this first half of the graph, and it definitely fails on the second half of the graph as well. So now we have a little bit of a challenge here. We're like, well, this whole graph fails. So for me to actually get it to be a one-to-one function, like we did with cosine, I have to limit its domain. But if I limit the domain from 0 to pi, it's not 1-to-1. And if I go from pi to 2 pi, it's not 1-to-1. So I literally have to back this up into fourth quadrant at negative pi over 2. And at negative pi over 2, remember it's the same as 3 pi over 2, we get, we get this, right? And then at negative pi, it does this. Agreed? Okay. So you're like, well, how do we limit the domain to make it a one-to-one function? Here's how we're going to do that. If I look at negative pi over 2 to positive pi over 2, and I kind of erase everything else, this will make it a one-to-one function, won't it? Which means I need to limit the domain for the sine function, and I need to limit the domain to go from negative pi over 2 to positive pi over 2. I'm only going to deal with this portion of it, and it's going to be a one-to-one function. And the range isn't going to change. The range is still negative 1 to positive 1. I still get some positive and negative y's in there, which is good. All right? Does this make sense? This is why the inverse functions, this is why the domain is different than the original domain of sine and cosine, because you have to limit the domain of the sine and cosine functions to make them one-to-one. All right, just checking. So let's go over here. Let's look at sine inverse. Now, Remember, this is my x, this is my y, right, axes. On the inverse, the x's and the y's switch. So the y's go from -1 to +1, which means those are now my x's. Which means the range becomes the domain. Yep. If the x's and the y's are the switching, the domain and the range is switching. Now, the x's become my y's. And my x's are going from -π/2 to +π/2. So -π/2 to +π/2. And yes, we still have 0 here. Which means if the x's became the y's, the domain has now become the range. Good? Okay. Now, this point was -π/2, -1, right? On the inverse, it's going to switch. So that's at -1, -π/2. This point, well, this point's easy. This one's 0, 0. You switch 0, 0, you still get 0, 0. Yay for that. This point was π/2, 1. Well, on the inverse, it switches. So it becomes 1 and π/2. Whoops, I don't need to write it. You guys are good. And so now when I connect my dots, I get a graph that looks something like this. You probably have it drawn better on your paper. But that's what the inverse graph is going to look like. And that's why its range especially is limited. Good? Okay. We still have the inverse tangent function to graph, so stay tuned for that. Again, rewind the video if you need to get a little more clarity on why we have to limit the domain on the original function, because we need it to be a one-to-one function, which means it has to pass the horizontal line test as well. Good? Okay, I need some board space. I'll be right back. Okay, ready to graph the last of the inverse functions that we're going to work with? Tangent inverse? All right, or arctan as it's called. It could also be called arc cosine, arc sine, and arc tangent. Okay, but before we graph the inverse tan, let's look at the tan function itself. So we're going to look at what the graph of y equals tan of x is. Now, if you remember, when you graph the tangent of x function, we go from -π/2 to +π/2 on the parent graph. These are the asymptotes, right? Okay. And I don't know about you, but when I learned to graph these, I had -π/4 and a +π/4 in here to help me actually do the graph. Because here's the deal. At -π/2 was undefined, tangent was. At +π/2 it was undefined. At 0, we just got 0. So we're like, okay, well, that doesn't help me graph. Well, when you take the tangent of -π/4, it's a -1. And at +π/4, it's a +1, which is why, and my graph isn't going to hit the dots, but you get where I'm going with this, right? These are my markers that actually helped me find what this graph looked like. And when I look at the domain and the range of tangent, the domain is -π/2 to +π/2, and the range is all real numbers. Well, interestingly enough, tangent isn't just a function. Tangent's already a one-to-one function. There's no overlap here. When I have a horizontal line, it doesn't cross the actual graph of tangent more than once. The asymptotes don't count as part of the graph. This is my graph of tangent, and the horizontal line only passes through once. So tangent, the parent graph of it, is naturally a one-to-one function, which is great for us because that actually gives me a hand of what the domain and the range is going to be for the inverse. So let's take a look at this. the inverse graph of tangent. So remember, the domain, the x's and the y's, so my x's go from negative pi over 2 to positive pi over 2, which means those switch over to now my y's. And that means the domain is going to be negative. I'm so sorry, I goofed in what I said. I'm so sorry. My x's become my y's. So my y's, my range, is going to be negative pi over 2 to positive pi over 2. And you're like, you still put parentheses. You're right, I did. Because these are asymptotes at negative pi over 2 and positive pi over 2 on the tangent graph. So on the inverse tangent graph, the positive pi over 2 and the negative pi over 2 are still asymptotes, but now they're horizontal asymptotes, the flip of vertical asymptotes. Remember, things are going to switch, but the asymptote will always be the asymptote. That doesn't necessarily switch, except instead of a vertical, the inverse, it's going to be the horizontal. Okay? Okay. The domain, or pardon me, the y values were negative infinity to positive infinity. Well, now those become the x's, which means the x's can go from negative infinity to positive infinity, which means my domain now goes from negative infinity to positive infinity. Remember, your domain and your range are going to switch. Okay, so now let's graph this. This point was easy. This point was 0, 0. Well, there it still is. Nothing's changing. These other 2 points are what's going to be very helpful. This point was negative pi over 4, negative 1. Well, over here, it's going to be negative 1 and negative pi over 4, so it's going to be down here somewhere. This point was positive pi over 4, positive 1. Well, on the inverse, it's going to switch, so it's going to be positive 1 and positive pi over 4, so it's up here somewhere. So when I connect my dots, and your graph may look better than mine, it's going to look something like that for the inverse tangent graph. Good? Okay. Again, we were fortunate with the graph of tangent. It was already 1-to-1. I did not have to limit the domain. The domain and the range switch because on the inverse function, because since this is 1-to-1, the inverse function, they switch, which means I did the same thing with these points, and now this is what the arctan graph looks like. Cool? Does that make sense? Okay, so graphing the arc, cosine, arc, sine, arc, tangent really isn't that bad. But on the arc, cosine, and arc, sine, we had to limit the domain so we could make them 1-to-1 so they could have an inverse. Cool? Okay, rewind is needed, re-listen is needed. You guys have fun with this stuff, and I'll catch you on the flip side.